All right, so in a question like this, I've given you pretty simple numbers here. If you have 0.00100 moles of HClO3, okay, that's chloric acid dissolved in 1 liter of aqueous solution, what would the hydronium ion concentration be? Okay, so this, when it comes to calculations like we're going to do, these are really simple numbers to work with. 0.00100 molar HClO3. Now the first concept that makes this easy is if you know this is a strong acid. Actually, this is molar. Moles of this, okay? It will be molar when we get to it because it's in 1 liter of solution. Okay? But if we have a strong acid, the lab we did in this unit was about strong acids and bases. Okay? So you could see the difference in the graphic or animation that I did at the end of the lab. After the lab was over, I showed you the difference between strong acids and strong bases in terms of looking at the individual particles. And we said strong acids are strong acids, and that's one of the questions on here, by the way, down to the bottom. To a chemist, what is a strong acid? What's a strong base? Number 12. A strong acid is an acid that dissociates completely. That means it completely breaks up. If we're using Arrhenius, we'll do it this way. ClO 1 minus, ClO3, yeah, 1 minus, right, I see what I said. Okay, if this breaks up, then whatever number of moles of this that I have to start with, it completely breaks up, they're gone. And I end up with that same number of moles of this. Remember the illustration I did where we talked about people going to the dance? If you got a mole of couples going to the dance, you also have a mole of guys and a mole of girls, right? Well, this is the same sort of thing. We're breaking it up. Here's our couple, here's the guy, here's the girl. Yes?
How do you get my quizzes back?
You might not get them back. I'll get them back to you as soon as I get them graded. Okay, I got a pile of late stuff coming in, and it's been taking a lot of my time, and my computer doesn't work like it's supposed to, and one thing and another. It's just been hectic, okay? But I'll get to it as soon as I can, all right?
Yeah, Mr. Teddy, one more question. During lunch, during second lunch, can I stop by here?
Yeah, sure. Okay, all right. So if I've got a mole of this, okay, all of this is going to disappear. Every bit of it's going to disappear, and it's all going to become these two separate things. 0.100, I'm sorry, 0.00100 moles and 0.00100 moles of this, okay? And we had this in 1 liter of HClO3 solution. Well, the 1 liter solution didn't change. Okay, it's still in 1 liter solution. But now it's the split up solution. So we could say H plus solution, couldn't we? Well, that's a molar. So the molar concentration then of H plus is 0.00100 molar. Okay? If we're doing pH, pH is an exponent, remember? And logarithms, pH is the negative logarithm of this number here. This number is the same as, by moving my decimal place 2 places to the right, 1, 2, 3 places to the right, I'm sorry. So 1.00 times 10 to the negative 3 molar.
Wouldn't it be 3?
No, if you move to the right, it's negative 3. Okay? So if we take the negative logarithm of that, we get 3. And we did that activity in class. We took a couple of exponents and played with it a little bit. All right? So you can see how that works. So if you understand all that stuff we've done in class, this one can be done in your head.
And that
all right?
That's the molar concentration?
This is the molar concentration of the hydrogen ion. And the whole hydrogen ion concentration is the same concentration as the hydronium ion concentration. Yes. This is just Arrhenius theory, and this is Bronsted-Lowry theory.
Now, how do you find it for the ClO?
You don't need to find it for ClO.
What if I got that answer?
Mm-hmm.
But I did it the way that I just did it.
Well, as long as you got the answer, I guess that's what matters, right?
Do that way, or do I need to learn how to do that?
I'm just.
I looked back on here today and I just put moles ones over, I put that first one was a 0.00.
Mhm.
Those are the one that I just divided and got 1.00 constant. I just divided it and put it inside of it.
That's fine.
That's how it comes out.
You can do it that way. If your calculator gives you an answer in scientific notation, that's great. Okay. Let's see. So is there anything else that I ask you for? Oh, okay. Once we know what the, let's see. This was number 3.
Predict the pH.
The pH then is going to be 3. POH then is,
-3.
no,
Hold on.
14 minus 3 is 11. Actually, I need 3 digits here.
POH, because you always minus it from 14.
Yeah. 14 is equal to pH plus POH.
Wouldn't that just be 11.0?
No, if I'm subtracting this from 14, I'll get to, there won't be any, okay.
Okay.
All right. Let's see, and hydroxide ion concentration. Well, it's easy to do it from the POH because to find the hydroxide ion concentration from POH, you take it to 10 to the negative POH. So that's 10 to the negative 11.
Hold up.
Yes.
When we're at the answer, does it need to be like, whatever the answer is, equals pH plus POH?
Well, you need to have this equation written out to show me where you got the answer from.
Does that need to be the final, I mean, if that's the final answer, does that need to be how it looks?
I'm not sure if I understand your question. So,
If 14 was your final answer, so you have to put equal pH plus POH.
depends on the question. Okay, you need to show me your work for your answer. Okay? All right, so I basically gave you some simple numbers here to make the math easy enough that, conceivably you could do it in your head.
So basically,
You thought
once
about
we
it.
find the
One person at a time, and really, I said a while ago, you need to raise your hand. Okay? Yes, Summer.
I don't really know the concept of how to do it. Like, I know that the numbers are simple, but I don't know, how to put
Okay, well, what was on page 367 of your text? That square thing with the graphic goes through all the steps? Okay?
we find the OH? OH.
How do you find the OH from, what do you start? What's
Once
your
we
start?
find the hydrogen, the pH.
Okay,
So once we find the pH, all we have to find the POH, we just minus the pH from 14.
right.
And then to get the KW's already given to us. Alright. That's alright. It's easy.
Yeah, okay. And you can find the hydronium, you can find this thing from the hydrogen ion concentration too, because KW,
Hey, is like the HClO3, is that going to be given to us on the quiz, or we got to figure out, or is it going to say like sulfurious acid?
it might give you the name of the acid, you have to figure out what it is. Okay?
Alright.
And so because these two numbers are equal, and you should know, and I think this is actually in your test references, that this is 1.00 times 10 to the negative 14 molar squared. If you know this in the problem, and now you know what this is, then you can solve for the unknown here. Okay, you could do it that way. It's a little bit more. Well, actually, let's see. This would be 14 minus a negative 3, so that would be 1 times 10 to the negative 11. You still get the same answer. So really, any of it would be pretty simple to do on that one. Okay?
Kind of, sort of. I mean, I can get the pH and POH.
Yes.
It'll take me a second.
Number 5, it was like 6 stones.
Okay, now I haven't answered number 4 yet. Somebody did ask about number 4. Do y'all want me to do number 4? You want number 4? Okay. Number 4 works much the same way. Okay? So we have a pretty simple number here. We've got 0.000100 moles of NaOH. NaOH is one of the strong bases. Okay? Strong bases are strong bases because they dissociate completely. So if you've got NaOH, let's see, actually, like I said, like there's a solid. Put it in water, you get Na plus OH. And so if this breaks up completely, if we start with 0.00100 moles of this, all of that's going to go away. And it's going to become 0.001, I'm sorry, it's 3 zeros, isn't it? 0.100 moles of this, and 0.000100 moles of this. Well, what matters for base is this stuff. And all this is in 1 liter of solution.
No, you say 0.000100
All right?
moles.
So because we've got this amount,
About 0.0001.
because we've got this amount of hydroxide in 1 liter of solution, the hydroxide ion concentration is 0.000100 molar.
Liter.
Huh?
Is it the same as 1.00 times
-3.
10
No, you're right, 4. Okay? Which means the pOH is 4, which means the pH is 10, which means the hydrogen ion concentration is 10 to the -10.
What was for it? Yeah,
What now?
I was pretty sure I got it out.
Okay.
The hydrogen?
What now?
What was the hydrogen?
The hydrogen ion concentration,
Excellent. No.
10 to the -10.
How is it? I thought the hydrogen ion concentration and the pH was the same.
No, pH is the negative logarithm of the hydrogen ion concentration.
10 to the -4.
Yeah, but you could write 1.00 times 10 to the -4 molar. Since a logarithm is an exponent,
Yeah.
and the hydroxide ion concentration, the pOH is the negative logarithm of the hydroxide ion concentration. The pOH then is 4. If the pOH is 4, you subtract that from 14 to get the pH, you get a pH of 10. If the pH of 10, hang on one second, the pH is 10, the hydrogen ion concentration is 10 to the negative pH, which is 10 to the -10.
How is the, I'm saying, how's the pH?
Because 14 is equal to pH plus pOH.
You said to get pOH. You said to get pOH, you take 14 minus pH a while ago.
Right.
Yeah, so wouldn't it be,
Okay, that's right. Never mind. I got confused.
no, pOH is just like the opposite of what the exponent is, right?
Right.
Is the
Negative
opposite.
log.
I think it's negative log of the acid,
Yeah. Yeah, this pOH is the negative log of this. Remember, logarithms are exponents,
yeah.
and if you're taking the sine inverse of this, it's 4. Or actually, 4.00 is what we should make it, and this should be 10.00 and so forth. Okay?
So pOH is the negative of the exponent. And to find pH, you just whatever. You just subtract the 14.
Oh boy, this thing's gonna be a
Just give it to me. Let's go. Come on.
Well, we got time. There's not necessarily any big rush. Okay? Do number 5.